Hello everybody and welcome. My name is Philip and I created this video course to demonstrate how you can easily design and develop your own game in Godot Engine. We'll be crafting a space shooter with 3D models, which is a great example to showcase a plenty of techniques and tricks. In fact, these skills can be valuable in many other game projects as well. Let's get started. I prefer to avoid lengthy introductions, so allow me to briefly outline the necessary tools we'll be working with. The best part is that all these tools are available for free. There is no need for any licensing fees, which means we can start working without any initial investment. First, Godot 4. The Godot Engine is the heart of our project, and we will develop all the game logic in it. The latest stable version at the time of recording this video was Godot 4.1.1. Please ensure you have the correct version of Godot to follow this course, as the scripts we will develop wouldn't work with the earlier versions. Second, Blender. I will demonstrate how you can utilize Blender to create nice-looking low polygon models for your game. Currently, I'm working with Blender version 3.6.1, and since we'll primarily focus on basic operations in Blender, it's likely that any 3.x version would be suitable. And third, Material Maker. We'll need to assign nice-looking materials to our assets, and Material Maker is just the right tool to achieve that. It's a free tool powered by the Godot Engine, and it proves to be incredibly valuable in streamlining the process of preparing game models. Currently, the latest version available is 1.3. And that's it. No additional installations are required to follow along with this tutorial. I've included download links in the video description, ensuring a seamless preparation of your local environment. So, if you are all set, we can dive right into working on the game. Let me show you again what we will start with. Godot, Blender, and Material Maker. And what we will end with. Just to remind, we're starting this project from scratch with no pre-existing assets, textures, or code. Our approach involves creating everything from the ground up, and I'll make sure to provide detailed explanations for each step of the process. Our first step is to open Godot and create a new project. If you read my book, you know that I usually start with creating a repository on GitHub and cloning it on my local environment. However, the video course is strictly about the game development, so I will skip the step related to version control, and in this video series, we will only work locally. Okay, let me switch to my working environment and I'll start Godot. On the startup, Godot displays the project manager window. You can see that I already have several projects here. Most of them are games I'm currently working on. We just click here to create a new project. We can keep all parameters with their default values because we'll be working on a desktop game. So I'll only select a new folder to create a project. Okay, where it is here, and Godot. Fine, and let's give it a name, Shooter. Good, create folder and create and edit. And the Godot environment opened. This is a blank project, nothing is there yet. Every Godot project is driven by one or more scenes, so we need to create a first scene. And since we are working with 3D models and operations, our choice is the 3D scene. But before we create a scene, there is one more important step to take. Let's set up the global settings. It's here in project settings. As we know, people who will play our game usually have displays with different sizes and resolutions, so it's crucial to be ready for that. I personally faced plenty of problems before my own game started displaying everything as I wished. I remember that the biggest issue was with 2D labels and the assigned fonts, as the wrong settings resulted in distorted texts that looked bad and were difficult to read. So to avoid such a situation, let's set this. Here in the stretch section, we'll set stretch mode to canvas items, and the aspect should be set to expand. This will ensure that our 2D elements will always be sharp and without any visual artifacts. I also recommend disabling the option for players to resize the game screen unless you specifically desire that functionality. Later, we will introduce a feature to modify the window size within the game. Now we uncheck this checkbox and the game window won't be resizable anymore. And one last thing, let's adjust the viewport size to 1600 by 900. It fits nicely within my laptop display with full HD resolution. Good, we can proceed with creating the first scene. Let's do it by specifying its root node, and which we will set to 3D scene. There it is. It's always a good idea to rename it to something more descriptive. So let's click it and give it some better name. For example, main root. Okay. We save the scene either by pressing Ctrl S or in the scene menu. Here, save scene, and give it main tscn. Okay, we have the scene, but it's completely empty. There's nothing in it. We'll start with adding two more important subnodes, the light source and a camera. For the light source, we choose a directional light 3D, as we need, at least at this stage, to have all the game objects equally illuminated. Let's right-click the root node and add a child node of the type directional light 3D. Cool. Okay, done. Now we need to configure it. As you know, we are working on a space shooter, and all its objects will be observed from the top-down perspective, which means that the global light source should be located above the XZ plane. Let's click the node to open it in the inspector. Here it is. And set the values of the position and rotation properties. They are located here in the transform section. So the position of Y should be 25. Now it's above the XZ plane. And the rotation, we will rotate it to -90 to point the light source directly at the plane. We will use the same approach to configure the camera. Let's add it to the scene first. Okay, child node and camera 3D. Good. Now, what kind of camera do we need? There are basically two options. They are set here in the projection. First of them, orthogonal. We will choose it to assemble a traditional 2D game with no depth perception. That would be perfectly fine and sufficient to create a playable and nice looking game. However, I would like to leverage certain 3D effects in this project, so we better select the second option, which is perspective. With this camera, objects will be perceived from slightly varied angles, and the visual scale will be influenced by the y coordinate. Furthermore, the space can be distorted at the edges and corners of the viewport, so it's important to reduce the field of view to mitigate that. Let's do it here. FOV, field of view, will set to 30 degrees. And again, we need to change the position. We'll set it above the exit plane to 130. And the rotation, just like with the light source, -90. Good. Finally, let's prepare several folders to keep various assets and make our project better organized. We will right-click here in File System, the root node, and create a new folder. Models, Materials, Scenes, and, for instance, Fonts. Good job. Let's execute the project. And it seems we didn't set the main scene yet. So we'll do it now. Godot already offered us to select the current one. Let's do it. And the game opened. Of course, there is nothing to see, but at least the game started. Now it's a good moment to add more elements to the scene. The initial element we will introduce to our 3D scene is in fact a 2D object. Why is that? The reason is that we want to establish a debug overlay which would be always on top and allows us to monitor vital aspects of the game, such as creation and deletion of significant objects, fluctuations in frames per second, which is closely related to the game performance, and so on. This debug overlay will provide extremely valuable during the development process. So let's create a new scene here in the File System panel. Right-click the Scenes folder, create new and scene. And for the root type, we'll choose the last option, node. Click the node selector and find label. Okay, because we'll display only text. Let's give it a name, debug, and OK. Great, the scene was created. Now we want to attach a script to it. This can be done in two ways. First, we right-click the node and select Attach Script, or we can just click this icon next to the search bar and use the same functionality. It's already pre-filled as debug GD. Let's use it and create. The script opened, so we can verify that it extends label, which is exactly what we wanted. Now we will display text, which means we must use some font. Actually, Godot uses system fonts by default, but I don't recommend do that because the fonts could be different on various platforms. So let's instead download and import a custom font. This can be done, for example, from the site fontsgoogle.com, which contains thousands of free fonts to use. So I already downloaded one suitable font. I have it prepared here. Let me drag and drop this file into the fonts folder. And here it is. The font was imported. Let's select the root node again, scroll down to theme overrides. Here we can open fonts and drag the font to the property to use it. And we will set the font size to 24 pixels. Okay, this should be prepared. Now it's time to implement the script. We don't need the function ready, which was pre-generated from template. Let's delete it. And we will need a switch to activate or deactivate this debug label because we don't want to use it once the game is finished. Let's add a variable, export and give it the default value true. This prefix, this annotation export means that the variable will be added to the inspector and can be easily we can easily change its value here without modifying the script. Now we will need some values to display. Let's prepare the variables. Okay, the first four variables are related to values we want to monitor on each frame. The last one, player, this is just a placeholder because we don't have a player object yet, but we will want to see some data related to playership here in the debug overlay, for example, its current position, rotation, and etc. So we will just make it ready here and prepare the function to initialize it later. Okay, now we finally need to fill the text property of this label to display something. So we will start with verifying if the overlay is active or not. So there will be nothing displayed. And now let's fill the variables. We will use we will use built-in functions, as Godot makes it easy for us. Frames per second, then draw calls would be filled from rendering server, and there is a method get rendering info. Yeah, and I think it is total draw calls in frame. There, this long constant. The next one is frame time, which is actually delta, because delta again is prefilled by Godot, and it is the difference elapsed time since the previous frame, which is exactly the frame time. And the last one, allocated video RAM. This will be again taken from rendering server. Get rendering info, and the constant is in this case video mem used, I think. Yeah, this one. Great. Okay, now we will create a long variable to concatenate these values into one label. Let's start. Okay, the function str is actually conversion from number to string, because Godot doesn't have an implicit conversion like other languages, so we must always convert everything to string to use the plus operator. It's not too aesthetic, but it will suit exactly what we need to do, so there is no problem with that. Very well. By the way, this backslash at the end of the line means that the line continues on the next line, so the Godot knows it is not finished here. Okay. And now we want to add the player data, but only if the player exists. Otherwise, Godot would throw an error. So we need to check that player is a valid object. It's not null. Data. Almost there. Just rotation. Okay. And finally, let's assign this data object to the text property. Cool, finished. Now, let's save the scene. Click back to the main scene and let's drag the new scene as a child node. Debug TSCN. Cool. Let's open the 2D view and properly position this element. We will set up the position here. I think it's here in layout. Yeah, not top left, but let's give it bottom left. And maybe transform. Yeah, it's already set up. So let's check it. Ah, here it is. So yeah, this is just the basis for the future debug panel with all necessary information. Right now we are finished with this part. There is one more thing I forgot, because nobody wants to see the VRAM value in bytes. We should use at least megabytes or gigabytes, so we need to divide it by 1024, convert to kilobytes, and 24 convert to megabytes. This is one thing. And the other one is that we should be ready for a situation when the player object exists, but it's not valid. So calling the properties global position and rotation would end up in error as well. To do that, we will create a global function that can be called from anywhere of the project. And for that, we will create a new folder called autoload. Autoload. There it is. And we will add a new script. We'll call it utils gd. Okay. Let's open it. Again, we won't need these functions because this is just a utility class. And now we need to add it to autoload settings. This is done here in project settings, autoload, and click the folder icon. Let's find the script. Godot automatically assigned a node name utils. We'll click add, and here it is. Now each time we need to access functions from this script, we will just use the prefix utils with capital U, and it can be used from any other script in this project. Let's close and let's implement a simple function. Func is valid node, parameter node to node, so which means it's not null, and is instance valid. There it is. Okay, and that's it.
Let's use Ctrl S to save the script. Switch back to debug overlay, and here instead of if player we will replace it with utils is valid node. Great, let's check it out. Yeah, I think it looks fine.